Here in section 6.4, we do adding and subtracting with the more complicated situation where the denominators don't start out already matching. Now, the rules, the steps, are actually very simple for this. First, build the lowest common denominator. Then, do adding and subtracting normally, because your denominators would match at that point. And then factor and reduce the answer you have at the end. But that makes it sound a lot simpler than it actually is. What we're going to have to do is we're going to have to go through several different examples that will slowly build up the complications one at a time, so that each weird little hiccup that you could run into, you get a chance to see how that builds and builds and builds to a full, massive, complicated problem at the end. So, as a warm-up, let's work this problem here. Press pause, try working it yourself, following the directions there, and then press play again. Alright, so to build the LCD, what you have to do is compare the denominators, see what each one is missing, and then include what they're missing. This fraction on the left is missing an x, and it's missing a y. So if we want to get it to have x squared, we need to multiply by an x. If we want to get it up to having a y cubed, we're going to have to multiply by y. And the basic rule of fractions is, if you multiply something in the denominator, you're going to have to multiply the same thing in the numerator. Second fraction. Well, it's pretty clearly missing a 3, so we're going to have to multiply top and bottom by 3. But x's, this had more x's than the other one did, so we don't have to do anything for the x's. Same thing for the y's. So, when I multiply these two fractions in this fashion, the denominators for both of them are going to be 3x squared y cubed. The numerators, this one will be 5xy, this one will be 18, and once you have the denominators matching, then you just combine the numerators. So we have a numerator of 5xy minus 18 over the denominator of 3x squared y cubed. That numerator doesn't factor any, so we're not going to be able to do any reducing here. That happens sometimes. Sometimes, maybe about half the time roughly, the fraction you have at the end is not going to reduce any. Always look for it. Always consider what if it factors, what if it reduces. But not every problem will have that happen. So, that problem there was simple because the two denominators were individual terms. They didn't have multiple terms to them. Here's a slightly more challenging one. So press pause, try this one, and then press play again. Okay, so remember, you don't get a common denominator by adding things to both sides. You get a common denominator by multiplying the top and bottom. So we can't make this match by adding 7 and then getting it to be y plus 4. We have to multiply by something in that fraction, and we have to multiply by something in this fraction, and eventually, when we're done, we want to have the same denominator. Well, unfortunately, there's nothing really pretty here. We're just going to have to multiply this fraction times y plus 4, top and bottom, and this fraction, top and bottom, by y minus 3. And then the denominator will be y plus 4 times y minus 3. And yeah, it's a complicated denominator compared to what we started with, but that's what happens when you build common denominators. They're more complicated. This first fraction, y plus 4 times y, you can't leave that factored if you're going to add it to the other fraction. So if you're going to add these numerators together, you have to have them multiplied out. And this is one of the things that's a little challenging about this. Your denominators, you're going to leave them factored. But your numerators, you're going to multiply them out. You're not going to leave them factored. So you do two different things. Denominators, factor, leave them factored. Numerators, multiply them out so that you can then collect your like terms. So here, my numerator is going to be y squared plus 16y minus 36. And there's a pretty good chance that we're not finished. That numerator looks to me like it probably factors, so you take a second to factor it, and sure enough it does, and it factors kind of awkwardly, y plus 18 times y minus 2. And the reason why you factor it is to look to see if it reduces. You can't really tell if it reduces unless it's factored. Once it's factored, then you can look at the numerator and denominator and see if there's anything that matches. And in this case, there's nothing that matches. So go ahead and leave your answer like that. Or if you just think it looks nicer, you could multiply things out. I'll accept it either way. This is kind of the lazy person's answer because you don't have to do any other steps. Multiplying it out would actually be more work. Alright, here's a slightly more challenging one. Press pause, try working this one through, see if you get the same answer I'm going to get in a moment. Okay, one of the key things here, this is based on what we did in 6.3, is that getting a common denominator, you won't get the lowest common denominator unless you first factor your denominators. So we're going to factor this denominator, factor out a 3t. That's going to leave you t minus 5. And in the second fraction, factor out a 2, and that also leaves you t minus 5. So what that means is, when you're building your common denominator, t minus 5, that's already common to both. The only things you have to do to make them match up is that this fraction needs a 2, and this fraction needs a 3t. So then, this fraction here is 16 over 6t times t minus 5. And this fraction is 9t over 6t times t minus 5. Okay, it's a subtraction problem instead of an addition problem, but that's the same basic idea as it always has been. You subtract the numerators. You get 16 minus 9t over 6t times t minus 5. And that numerator doesn't factor at all. It looks like maybe it's a difference of squares, but 16 is a perfect square, 9 is a perfect square, t is not a perfect square. So it almost, but not quite, factors. And if the numerator doesn't factor, and we don't have anything that matches, then it won't reduce any further than what we've already got. So when we say factor as the first step of these problems, factoring means setting the denominator up so you can find the lowest common denominator. That's the purpose here. This next example is going to be kind of a tricky one, so I'm going to just jump right in and walk it all the way through from beginning to end. The real trick here is the denominators could be factored. They are difference of cubes, but that doesn't really help you do the problem any. In fact, what helps you do the problem is if you notice that these denominators already almost match perfectly. They're quite similar to each other. In fact, the way they're different is they are exact opposites. Notice one of them has a positive 1, one of them has a negative 1. One of them has a negative m cubed, the other has a positive m cubed. They are exact opposites. So when you're looking at a problem where you have exact opposites, there's a shortcut. And the shortcut is to take one of the fractions, doesn't really matter which one, totally up to you. Use the first one, use the second one, doesn't matter. But multiply one of the fractions top and bottom by minus 1. So what I'm going to do is I'm going to take the left-hand fraction here, and I'm going to multiply the top and bottom by negative 1. So what that does is, this is going to be negative 1 plus 6m, which is probably more convenient to write that as 6m minus 1. And this will be negative 1 plus m cubed, so that'll be more convenient to write m cubed minus 1. And when you do that, you have a common denominator already. You could factor those denominators, but they'll match factored or not factored. And what you're trying to accomplish here is to get a common denominator, and we did that. So once you have a common denominator, then you can go ahead and add or subtract your numerators. So in this case, it's going to be subtract numerators, making 6m minus 6. And then you've got your very final step of all fraction problems, which is factor and reduce. In the numerator here, you can factor out a 6. And now we finally have to deal with the fact that the denominator is a difference of cubes, and a difference of cubes factors in the normal difference of cubes way. So it factors m minus 1 times m squared plus m plus 1. As always, if something matches in the numerator and denominator, you're expected to reduce that. We end up with 6 over m squared plus m plus 1. Okay, two more examples to take a look at. One that's fairly straightforward and one that's a little more challenging. Here's a fairly straightforward one. You're going to want to pause the video in a second, but let me give you a bit of advice. Start by factoring the denominators, then worry about what the common denominator is. Your life will be a lot easier if you factor the denominators first. So go ahead and give that one a shot, and then press play when you're done. Okay, so this first fraction, its denominator, factors into x plus 2 times x plus 3. I just realized I need a little more space. Let me scooch that sideways. There we go. The second fraction factors into x plus 2 times x plus 1. So, the x plus 2, that's already common to both. The fraction on the left, what it's missing is an x minus 1, or x plus 1. The fraction on the right, what it's missing is an x plus 3. And when you multiply the tops out, you get x squared plus x, and this one comes out, well, here's a trick. I'm going to distribute in both these to that. That's going to turn it into an addition problem, which is good, and it'll also make it easier to be sure that I get that minus 6 at the end and I don't forget about the minus sign. Both of these have the same denominator. The denominator is x plus 1 times x plus 2 times x plus 3. And if you get tired of writing that, you could just write d for denominator as long as you remember what it is, and it's like a shortcut. Why write the thing over and over and over and over again? Like in our next step here, where we add the numerators together, x squared minus x minus 6 over, yet again, the same denominator, x plus 1 times x plus 2 times x plus 3. Don't forget when you're all done that you need to factor and reduce. This factors into x plus 2 times x minus 3. And here's where you probably ought to actually write out that denominator again, so that you can do your cancellation. The x plus 2 cancels the x plus 2, and we're left with a numerator of x minus 3 and a denominator of x plus 1 times x plus 3. Okay, one last example. Press pause, try it, and see if you get the same answer I get. Did you get an answer of 2? If not, here's how you do it. This fraction needs an x plus 2 to create a common denominator. This fraction needs an x plus 3 to get a common denominator. And then they'll all have the same denominator, which I'm not going to write over and over again. This numerator will be x squared plus 7x plus 10. This numerator will be x squared plus 10x plus 21. And when you combine all those numerators together, you get 2x squared plus 10x plus 12, which factors and reduces into 2.